All right, let's jump right in. We're talking about industrial cybersecurity today. And honestly, this is a topic that's getting more and more critical every single day. I mean, think about it. Our power grids, our factories, our water systems, they're all coming online. So, we're going to break down exactly how you defend these incredibly important systems.
And this, right here, is the absolute heart of the problem. These industrial control systems, or ICS, they were originally built to be completely cut off from the world, running on their own special hardware. Security? It wasn't even on the radar. So the real question becomes, how in the world do you build a digital fortress around a kingdom that was designed with no walls to begin with?
And that leads us straight to this idea of the fragile kingdom. For decades, these industrial networks were their own little isolated worlds. But now, the office IT networks and the operational OT networks on the factory floor, well, they're starting to speak the same language. We're talking Ethernet, TCP/IP, the stuff your home computer uses. And that means they're suddenly vulnerable to the exact same threats.
Now this is where you see a massive clash of cultures. In the regular IT world, what's the #1 rule? Keep secrets. Confidentiality is king. But you hop over to the operational or OT world, and their #1 rule is completely different. Keep the assembly line running. Availability is everything. You can't just take a power plant offline for a security patch, right? This one difference changes the entire security game.
And this quote just perfectly captures the danger. It's actually pretty terrifying. Picture an attacker targeting a boiler. They don't need to cause a big, loud shutdown. No, they just have to subtly change the numbers the operator is seeing. If they make the operator think the boiler is running cool, that person, just trying to do their job, might crank up the heat, and boom, a physical disaster. The attacker didn't break availability, they corrupted the system's integrity.
Okay, so we get the problem. It's complex, it's scary. So what do we do? Well, the first step is to architect a solid defense. We're going to really lean into this idea of building a digital fortress with multiple layers of defense to protect those crown jewels right at the very center.
The name of the game here is segmentation. It's all about building walls. You start on the outside with the corporate enterprise network. Then you create a heavily guarded buffer zone, the IDMZ. Deeper inside that, you have the industrial zone. This is where the really sensitive machinery lives. And then, for the highest level of security, you build more walls, called microsegments, inside that core. It's like putting vaults inside of vaults, making it incredibly hard for an attacker to move around if they ever get in.
So let's talk about that buffer zone, the Industrial Demilitarized Zone, or IDMZ. You really should think of this as the main gatehouse to your entire fortress. Absolutely nothing gets in or out without being inspected. It uses firewalls and special servers to act as a super strict checkpoint, making sure every single packet of data trying to cross between the business side and the factory side is supposed to be there.
But here's the thing. A fortress, no matter how well built, is totally useless without guards on the wall. After you build the architecture, you need to watch it constantly. This is not a set it and forget it kind of deal. You need nonstop vigilance. And we're going to look at 3 key ways you achieve that.
First on our list is passive monitoring. Now, this is like having guards who are professional spies. They are masters of observation. The key here is they don't poke or prod any of the sensitive industrial equipment. They just listen. They watch the network traffic go by, they read the system logs, and they look for anything that seems off, all without any risk of accidentally tripping something up.
And of course, there are tools for the job. A CM, for example, is like the central command post where all the reports and logs from across the kingdom are gathered. A NIDS, a network intrusion detection system, is like a sentry on the wall that has a list of known bad guys to look out for. And then you've got powerful platforms like Security Onion that can actually bundle a lot of this stuff together for you.
All right, next up is active monitoring. And if passive monitoring is all about quiet listening, well, active monitoring is about going out on patrol. These are the guards who are walking the perimeter, they're checking the locks on the doors, they're asking questions. They carefully send out signals to systems to see what's running and if there are any known weak spots.
The classic tool here is something called Nmap, which is fantastic for finding out what's on your network. But what's really cool is how you can use specialized scripts to talk directly to the PLCs, the brains of the industrial machines, in their own native language. This is how you find out really specific stuff, like what version of firmware they're running, which can tell you if they have known security holes.
And finally, we have threat hunting. This is the top-tier, elite detective work. You know, your automated tools, your alarms, they're great, but a really sophisticated attacker might be able to sneak past them.
Threat hunting is where a human analyst proactively dives into the data, looking for those super subtle clues and weird anomalies that the automated systems might have missed.
And threat hunters have their own special toolkit. A tool like Rita, for instance, is amazing at finding what we call beaconing. That's the classic sign of malware inside your network quietly phoning home to its master. It's all about finding the faintest digital fingerprints that an intruder might have left behind.
So, what happens when one of those guards, whether it's an automated tool or a human hunter, finally sounds the alarm? That's when your incident response plan kicks in. And this is not about running around in a panic. It's about having a calm, practiced, well-rehearsed battle plan to shut down the threat and get back to normal as safely as possible.
This whole process breaks down into 6 clear phases. It actually starts way before an attack with preparation. Then, when the alarm goes off, you move to identification. Is this a real threat? Then, the most crucial step, containment. You have to stop the bleeding. After that, you eradicate the threat, recover your systems, and maybe the most important step of all, follow-up, so you can learn from what happened and make sure it never happens again.
So we've got our fortress architecture, we've got our guards on the wall, and we've got our battle plan. But how do you know any of it actually works without waiting for a real live attack? Well, that brings us to the final and maybe most important concept, the proving ground, the ICS lab.
An ICS lab is an absolute game changer. It's basically a safe, separate sandbox that looks and feels just like your real factory floor. This is where your team can go to wargame. They can test new security tools, they can practice their incident response to simulated attacks, and they can learn the ins and outs of their equipment, all with zero risk to the actual power plant. It is the ultimate training ground for your defenders. And all of this, it brings us back to one final huge question. We know how to build a fortress, we know how to post the guards, but how do we do all of that without grinding the kingdom's work to a halt? Finding that perfect balance between rock-solid security and the constant demand for operational efficiency, that's not just a tech problem. It's the core strategic challenge for anyone tasked with protecting our most critical infrastructure.